In the previous video, we took a look at using wildcard masks as part of an OSPF network statement. And in that lab and exercise, we focused just on clean boundaries. What do you mean, like a fence? No, a clean boundary where the network portion and the host portion, the dividing line is right between two octets, right? A nice clean dividing line. But if an organization or a network is using subnets, where we're not using a nice clean boundary between two octets, the wildcard masks become a little bit they look a little bit different. But what I'd like to do is share with you a couple of techniques that we can use to get the correct network by using the correct wildcard mask every single time. And that's what I'm going to share with you right now. So let's use these four networks, these four subnetworks, and look at the OSPF wildcards. And specifically, the importance here is that these are not falling, the boundary between network and host are not falling cleanly between octets in the 32-bit IP address. So we have a 27-bit mask, a 28-bit mask, and a 29-bit mask. And this concept applies to any network. So over here on the left, we have four networks. Those really are four networks. But the focal point here is the actual mask length. So I would recommend the exercise to be this. To calculate the wildcards, what we're going to do is we're going to put the normal mask in. So in this case, a 27-bit mask would be 255 here. That's 8 bits. 255, that's 8 more for a total of 16. We have 255 here for 24, and we need 3 more, which would be 224. If you don't have those quite memorized yet, like what are the 3 bits that are on, you could always do this: 128, 64, 32, 16, 8, 4, 2, and 1. Or you could start from this side and just keep doubling it, and then you could just make little marks. Okay, so 3 bits, 1, 2, 3, and add those 3 up, and boom, that would equal your 224. So any way you want to slice that is great, but it'd be important to become comfortable or at least be aware of how to reach that number, and that's been taught in a previous skill. All right, so this is the mask based on this last 27. What would the wildcard mask be? Well, Keith, you said earlier in the previous video that the mask and wildcard mask are like flipped, inverted. If we think of the M and the W, we can kind of think of them as inverted from each other. So that means if this is a 255, all ones, this is going to be a 0, all zeros. If the mask is 255 again, same thing there, and same thing there. So what do we do about this bad boy? This is where we are going to have to, well, you can either learn it and memorize it, or you can take it to binary and figure it out every time. And I would recommend we do that. So if we know this mask is 224, so in binary it would look like this: on, and then off, 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 off. That's what that is. And then we can say that's the mask. Well, if the wildcard mask, remember the inversion here, if the wildcard mask is inverted from the normal mask, what would it be here? And if the light bulb was going off saying, oh, I get it, we just do a binary inversion, you'd be right. It's the same concept, but we're just doing it in binary here. So if the mask is a 1, the wildcard mask is going to be a 0. If the mask is a 1, 0, 1, 0. And then over here, if the mask is a 0, the wildcard is going to be a 1, and that continues on. They're inverted, M and W. I don't know why, it's like a gift. It's like a little present. Then what we do is say, great, so here is our wildcard mask for that 4th octet. What is that value in decimal? Add them up. That's what I would do. 16 plus 8 plus 4 plus 2 plus 1. Or you could say it's 32 minus 1. That also works as a shortcut. Or you could also say it's 255 minus this value of 224. It doesn't really matter if you have a shortcut or not, because just adding them up works. 16 plus 8 is 24, plus 4 more is 28, plus 2 more is 30, plus 1 is 31, and that's what it would be. The wildcard mask would be 31 in that last octet. It's simply inverting the bits. And if some of you are thinking, wait, what was that shortcut again? The shortcut would be, you can take the dotted decimal value of the mask in that octet and subtract it, so 224, from the max value of 255 is going to be 31. So if you want to practice both ways, that's great, as long as you can calculate what it's going to be. So let's get back to our whole point here. If we're adding this network statement, we type in router, OSPF, our process ID, press enter. And then for our network statement, it would look something like this: network. We'd put in the network. There it is, 3120, space, and our wildcard mask would be 0.0.0.31. And then we'd add the command area, And then we'd add our area number to include that network in that area. That's how it works. That's how it works. So let's do 3 more on paper, and then I'm going to turn you loose on the lab so you can actually verify that your network statements that you're calculating and that we're doing here are correct. All right, so this network here has a 28-bit mask. So in dotted decimal, that mask would be something like this. So for that last octet, we're 4 bits in. So this one, I'll just circle it here. So we're that far over. So 128 plus 64 plus 32 plus 16 is 240. That's great. That's the mask. And the wildcard mask would be 0 for that one, 0 for that one, 0 for that one. So if these 4 bits are on and these bits are off, we're talking about this 240, we'd have a 0, 0, 0, 0, and then the wildcard masks would be on here, on here, on here, on here, and then we'd add up those 4, the 4 that are on, which is 8 plus 4 plus 2 plus 1, which is 15. Now, is it true that we could take 255 minus the mask of 240 and get 15? The answer is yes, we could. I just want to make darn sure that you're seeing that we're inverting it. So this is just a shortcut. We're simply inverting the bits in the wildcard mask. This wildcard mask for this network is going to be the same, 0, 0, 0, 0, 15, because both networks have the same mask. And for the final one, we have 29. And let me, I need some more space. Let me do it over here. Let's do it over here. So this is going to be 255, 255, 255. And then for 29, it'd be 1, 2, 3, 4, 5, and that's it. So if this is the octet boundary, it'd be 25, 26, 27, 28, 29. Great. So there's our mask in binary, and in dotted decimal, that'd be 248. And so what we could do here is we could flip all these bits, 0, 0, 0, 0, 0, 1, 1, 1, and that equals 4 plus 2 plus 1 equals 7, which is great. So our network statement for this guy would be network 3.1.2.64. That's the network. Then our wildcard mask would be 0, 0, 0.7, and that would include it in the network. So here's what we get to do now. We've practiced this a few times on this paper. If you want to review this video a couple times and do it by hand as well to reinforce it, that's great. Let's go to the lab and actually implement these 4 networks. We'll verify that those 4 networks exist on router 1. And then once we verify that they exist, we'll go ahead and add 4 network statements to include all of them using the appropriate network statements and the appropriate wildcard masks. All right, so here in ART1, let's do a show, IP, OSPF. I just want to make sure OSPF is not already running. So there's no OSPF running. Let's start it by going into configuration mode, router, OSPF1, press enter, and let's take a look at the routes. Make sure we have those networks to begin with. So we'll do a do show IP route, press enter, press spacebar to see the rest of the page, and here are the networks that we're after. We are after the 3.1.2 with a 27-bit mask, the 3.1.2.32 with a 28-bit mask, the 3.1.2.48 with a 28-bit mask, and this bad boy, the 64 subnet with the 29-bit mask. So let's add them. So here in router configuration mode, we'll type in network space, and I'm going to just do a little copy paste here. So since that literally is the network, I'm just going to click and drag across it, right click, pops it down there, and then I'll put in the wildcard mask of 0.0.0. And the wildcard mask for that one was 31 because it is a 27-bit mask. And we did the calculation for that earlier. Space, area, 0, and press enter. So then we can just verify as we go through that that network statement brought in that network. So we'll do a do show IP OSPF interface brief, press enter. And sure enough, we got it. Awesome. 1 down, 3 to go. So we'll do a network statement again, and then we'll go for the network 32, which is this bad boy right there with the 28-bit mask. So we'll bring it down. And then for the wildcard mask, it's going to be 0.0.0. And then let me look at the mask again. So it's a 28-bit mask. And we did the calculation on that earlier as well. And that is 15. And that's going to be in area 0. We'll hit the up arrow key a couple times, hoping for 2 interfaces. So far, so good. We'll go ahead and add another network. And we'll do network. And this time we're after network 48. So we'll just go ahead and grab it, right click. And then the wildcard mask for that is going to be the same, which is 0.0.0.15. Also put that in area 0. Up arrow a couple times to verify. Fantastic. And one more. And that is off my screen. So I'm going to scroll up just a little bit. and I'm going to grab it right here. That's the 3.1.2.64 network with the 29-bit mask. And then we'll type in network space, and we'll right-click to paste that. There's the 64 network with the wildcard mask of 7, based on our discussion from earlier, and we'll put in area 0. Okay, let's do a show IP OSPF interface brief. And survey says all 4. Now, this may not come as any surprise, but this is going to take a little bit of practice, both in writing out and doing the math on what that wildcard mask should be, and also practice in implementing it and verifying it. It is worth the time. You may want to watch this a couple times, maybe work on it with some pen and paper or digital media, whatever works for you, to practice it out, to calculate it, and then get that hands-on in the lab or elsewhere to practice it and verify it that you have it correct. Now, let me share with you one other thing about wildcard masks. This isn't one of those things that's going away because a wildcard mask is not only used as part of network statements in OSPF, they're also used as control lists, which we're going to cover later when we do skills regarding security and controlling traffic through our network. So take some time now, make sure you're comfortable with the concept of that inverted mask, the wildcard mask, and practice it while you have the opportunity, because we're going to leverage it again and again. So have some fun with the lab, enjoy the video as many times as you'd like to, and I'll see you in the very next one. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.